in this problem, you're given the mass, you're given the radius, and you also given the angular velocity and the total angle. That you need to find it out what is the torque acting onto the system. Let me explain this one. So you have a uniform sphere. So this is a sphere, and this sphere, for example, Earth, is spinning about its axis here. This is spinning about its axis. So it is spinning about its axis here. And then initial angular velocity is given. So let's write down all the information here, the given information. Given. The mass is given, which is 1.85. The diameter is given, which is 45 centimeter. If you know the diameter, you can calculate the radius, which is d over 2. 45 over 2 is 22.5 centimeter. You need to change this centimeter to the meter. So if you do that, you'll get 0.225 meter. This is in meter now. And then it's also saying the angular velocity. Angular velocity is denoted by omega. Is given 2.40 revolution. This is revolution per second. So if you see, if something is rotating in one complete revolution, the total angle it makes is 2 pi. Okay, if something is rotating, if you rotate one time complete, then the total angle it moves is exactly 2 pi. So you need to change this one into the radian. So the way we do it, you just multiply this one by 2 pi. Let me write down here 2 pi, 2.40 times 2 pi. If you multiply by 2 pi, then it becomes radian per second. Because in one complete revolution, the total angle is 2 pi radian. Okay? So just plug in all the numbers here, and you will get is 15.1 radian per second. Okay, you given and the total angle is given, is saying the 18.2 revolution. Here the revolution is the angle. Okay, it's 18.2 revolution. So in one revolution, again, what's the angle, total angle, which is 2 pi. So if it has completed 18.2 revolution, the total angle is 18.2 times 2 pi. Plug in all the numbers, and the total angle you will get is 140.3 radian. Okay, 114.3 radian. And now we have to use an equation to solve this problem here. I'm just erasing this part here. So we know that in linear motion we use v squared is u squared plus 2 h, if you remember, in translational motion. But in now we're talking about the rotational dynamics or rotational motion. So instead of using the v, we have omega squared. This is the final angular velocity, and this is omega naught squared, initial angular velocity. 2 is a constant, and this is a linear acceleration. And in rotational dynamics, you will use alpha as an angular acceleration. This is the distance In rotational dynamics, the distance is the angle, how many times it has moved. So this is the theta. So this is the formula we're going to use it now. And it says after 18.2 revolution, it comes to a stop. Okay, so the final angular velocity is equal to 0. And omega naught is given here. And I'm just calling, this is initial, so I'm just putting omega naught, omega 0, because 0 represents initial. So this is 15.1. 15.1. Okay. You can put the negative sign or you just solve for it and you'll get alpha as a negative. It doesn't matter. It just gives you the acceleration, or what you call de-acceleration. Okay. Or I'm just putting the positive sign here 2, and you should be getting alpha as a negative. You need to calculate alpha, and the theta is here is 114.3. This value is 114.3. 114.3. Solve for alpha. Once you solve for the alpha, you will get close to 1 radian per second square. This is the alpha you get. What does the negative mean here? The negative simply means the angular velocity is slowing down. Okay, that's what the negative means here. And we given a sphere. What is the moment of inertia of a sphere? Okay, now next thing is we need to little bit down moment of inertia of a sphere. The moment of inertia is same as the mass in rotational dynamics. Okay, this is equal to, if you have a sphere, a solid sphere, this is equal to 2 5 m r square. 2 over 5. The mass is given, which is 1.85. Radius is given 2. Let's put in a small r here. The radius is 0.225. So once you plug in this number, the answer you will get is the moment of inertia you will get is 0.0374 kilogram meter square. This is the moment of inertia, you will get it. And now the last thing is finding the torque now. The torque is I times alpha. And it is the same as using F is equal to ma. In linear motion you have F, but in translational motion you have torque. In linear motion you have mass, and in rotational motion you have I. And this is the linear acceleration, and you have angular acceleration. So plug in all the numbers here. What is the torque? What is the moment of inertia? 0.0374. 0.374. What is the alpha? The alpha value already have calculated, which is close to -1. You don't need to put the negative. This is 0.0374 negative here. The magnitude is simply equal to 0.0374 Newton meter. So the negative sign simply tells you the force is stopping down or slowing down the angular velocity. It is coming to rest at a certain point. That's what it means. Okay.